Okay, we're officially recording. That way this session can be available for people later. We'll post it on our YouTube channel. At the end of this webinar, we're going to do a survey as well in the chat box. If you guys complete the survey with your email address, then we'll send you out the direct link to this recording, as well as any follow-up resources that come up in the conversation today. So today I'm going to introduce our presenter. This is Nikhil Schneider. He's going to be talking about water and power at CSUN. Nikhil earned his Bachelor of Science degree in Environmental Science with a minor in Energy and Sustainability from the University of Houston in 2016. Since joining CSUN's Energy and Sustainability team in September 2017, Nikhil has played a key role in the university's sustainability efforts. He has captured over $70,000 in incentive funding from the utility companies and helped the university achieve hundreds of thousands of dollars in energy savings. As a bicycle commuter, Nikhil was instrumental in CSUN's recognition as a bronze-level bicycle-friendly university. He has also helped the university earn recognition as a Tree Campus USA and B Campus USA. So he has given numerous lectures and conference presentations, and he's excited to speak with you all today about water and power. So we're going to go through his presentation. If you guys can hold questions to the end, you can either put them in the chat box, raise your hand, and we can try to call on you, or ideally, if you guys want to unmute yourselves or go on video at the end and ask your question live for Nikhil. So without further ado, let's let Nikhil get started.
Thank you very much, Sarah. Is everyone still able to see my screen? The little sharing box went away.
I can see it, so
okay, great. And then I will say that we have 2 or 3 quick short polls for people throughout the presentation. So just be aware of that and be ready to select some multiple choice options. So thank you all for being here. As Sarah mentioned, my name is Nikhil Schneider, Energy and Sustainability Coordinator at CSUN. Here's a brief outline of what I'll be discussing today. So we'll start with the water energy nexus, and then I will discuss water in Los Angeles, water, power, and sustainability, and then lastly, water and power at CSUN. So when I say power or energy, I'm mostly referring to electricity, but you can also think of power as the ability to do work, which will make more sense as we dive into our first topic. So what do water and power have to do with each other? Well, as a city and even as a nation, our water and power systems are very dependent upon one another. They're very closely linked, and this linkage is what we describe as the water energy nexus. So you can't have one without the other, and you can't impact one without impacting the other. Might be odd to think about, but water is actually one of our oldest power sources. So to understand this linkage, we can go back thousands of years before people were using electricity, long before we had electricity or fossil fuels. So how did we harness the power of water back then? Well, first would be transportation, right? Why walk a long distance or carry goods a long distance if you can put them in a boat and let flowing water move them for you? Later on, we put sails on boats to harness wind power as well. But before we had wind-powered transportation, we had that water-powered transportation. Later on, people built mills to capture the mechanical energy of water and turn that power into a different useful format. Right, so lumber mills and grain mills were built along rivers because it's a lot easier to let the constant flow of water power a saw to cut lumber or spin a stone to grind wheat into flour than it is to manually do those activities with human power. So here you can see, a mill wheel harnessing the power of water and turning that into something else useful. Moving into the more modern age, we have hydroelectric power. Hydro meaning water, and electricity, of course, or electric meaning, of course, electricity. So how do you take the energy from flowing water and turn it into electricity? Well, the most common method of generating electricity is to spin a round magnet next to a coil of copper wire. And this moving magnetic field causes electrons to flow through the wire into people's homes where they power light bulbs and other electronics. So we were already using water to turn millstones and saw blades. So it was easy enough to instead have that flowing water spin a turbine attached to a magnet and generate electricity that way. Wind turbines actually operate on this same principle. Where they turn that rotational energy into electricity. And then lastly, we have thermoelectric power, which is how we generate about 90% of our electricity in the United States. Thermoelectric meaning heat and electricity. So how do you take energy from something hot, like burning coal, and turn it into electricity? Well, heat itself won't spin a turbine, but what will spin a turbine is actually something you can see right here in these images, which is steam escaping from a power plant. And you get steam by heating water. So what we do nowadays, in about 90% of electricity in the US is produced by boiling water, which produces steam. That steam spins a turbine like the one you see in this picture, and then that turbine is attached to a magnet, which spins, generating electricity. So this process varies greatly between different regions in the US. So we're going to look specifically at electricity generation for the city of Los Angeles. So LADWP stands for the Los Angeles Department of Water and Power. And this is a breakdown of the primary sources of energy used to generate the electricity that they provide to their customers. So Sarah, if you would activate our first polling question, which is, which of these generation processes does not require water?
Launching now. Okay, hopefully everybody can see the poll. So go ahead and select your choices.
So out of all these listed, which ones do not require water? Let's give it 10 more seconds. All right, are you able to share the results, Sarah?
Yep, let's end polling.
All right, yes, wind is way up there, and wind is correct. And I think, oh, solar was not on the list. But yeah, so wind power and solar power are both methods of generating electricity that don't actually require water as part of that process. But as you can see, they only make up about 24% of our total electricity in DWP, which means that the vast majority of our electricity does require water throughout its production process. And what we know from that is that saving water saves power. While wind and solar don't require water to produce electricity, it does require water to make wind turbines and solar panels. So unfortunately, power generation is not the only process that needs water, right? Manufacturing of different items also requires water. So if Sarah, you would activate the second polling question.
Question 2 is launched.
All right, so which of these other processes require water? And you can select more than one. All right, you want to share the results for this one, Sarah?
Looks like there's still people voting. Give it another 5 seconds.
Oh, that's right. Okay.
Last chance, get your votes in now. Okay.
So really, we should have had an all of the above option for this question because every single one of these processes does require water. Which brings us to the next topic, which is embodied water, or the water footprint. So embodied water can be defined as the total water consumed in each step of the supply chain for any product, mining, growing food, processing raw materials, refining them, manufacturing, packaging, shipping, manufacturing the packaging, everything like that. So what does this actually look like for certain products? We're going to take a look at some food items because food is probably the single largest water consumer worldwide. And as you can see, gallons of water required for 1 pound of food. A lot of, certain food products are very water intensive. It requires a lot of water to produce almonds and beef, for example. You will see a lot of the animal products on the higher end of that spectrum because, not only do the animals consume water, but they consume lots of feed and it requires water to grow that feed as well. So this is why, whenever people talk about being a smart consumer and, some people are vegetarian for environmental reasons, this is one of those reasons. And other products have a water footprint as well. In our last session, Dr. Chung mentioned a few of these products, which brings us to our third poll. So we have a cotton t-shirt, polyester t-shirt, denim jeans, and leather shoes. So which of these 4 do we think requires the most water to produce? Which of these 4 has the highest water footprint?
Let's see. Here we go.
Want to show us the answers, Sarah?
Yep.
Leather shoes. Yeah, so you all are correct. As I mentioned, animal products are way up there. And as you can see, leather shoes have the highest water footprint out of all of those. Interesting note, the difference between a cotton t-shirt and a polyester t-shirt, that was pretty surprising to me because I would think they're both t-shirts, kind of similar amount of raw material. But growing cotton, and refining it, as we saw in the last session, requires a lot more water than, spinning recycled plastic into polyester. So maybe next time you're purchasing t-shirts for an event, look at the option that uses a lot less water. So now we're going to dive into the water supplies for the city of LA. This is a breakdown of LADWP's water sources for 2011 through 2015. Unfortunately, there was not more recent data available, so this is what we're looking at. If you see this unit AFY, that stands for acre feet per year. So 1 acre foot is a volume of water equivalent to 1 acre, 1 foot deep. So imagine about 90% of a football field covered with a foot of water, and that is 1 acre foot. So as you can see, most of our water came from MWD, which is the Metropolitan Water District, and that is a group of local governments dedicated to sourcing water for their citizens. And MWD gets water from the California Aqueduct and Colorado River Aqueducts. So in this map over here on the right, you can see the California Aqueduct flows about 444 miles, brings water from the Lake Oroville Dam and flows diverted from the San Francisco Bay and Sacramento San Joaquin River Delta. So that water originates way up north and then flows over 400 miles south to Los Angeles. And then when MWD also operates the Colorado River Aqueduct, which carries water about 250 miles from the Colorado River into Riverside County. And then lastly, we have the LA Aqueduct over here in the middle, which brings water from the Eastern Sierras and the Owens River Valley south to Los Angeles. So there was a lot of controversy when the LA Aqueduct was built, and there's still actually a fair amount of controversy around that project. We'll dive into that later. I would say the key takeaway from these images is that very little of LA's water supply is local. Only 12% of our water supply for this 5-year period came from local groundwater sources, and the vast majority of it was imported. So it just kind of illustrates the challenge of having millions of people living in an area that does not have the water supplies to support that. This right here is I guess you could call it a table of water allocation amounts. These numbers are in acre feet, and this came from DWP's urban water management plan. But it kind of illustrates how all these different communities are allocated different amounts of water. As you can see, second from the bottom, we have the Metropolitan Water District of Southern California with almost 2 million acre feet, far, far more than any of these other smaller communities. But there are water authorities that kind of divvy up, they say this is how much water is available, and then divide up how much each entity is allowed to use for their own citizens. This new chart on the right, I just wanted to show to kind of illustrate the sheer amount of infrastructure that goes into something like an aqueduct. On the previous right here, just looks like one simple little orange line, but there's really a whole lot that goes into it. And I think this even further illustrates the extent to which our water and power infrastructure is intertwined. Every one of these dots represents either a pumping station or a lake or a generating plant. So obviously those pumps rely on electricity to move water. And then in some places, that flowing water is actually generating electricity, but further showing, kind of the interdependence of our water and power systems. So as I mentioned, groundwater is about 12% of LA's supplies, at least during the year range I showed you. And this is kind of a breakdown of the different regions within LA that supply that water. A few different challenges with groundwater, one of which being it recharges via rainfall. So you need rain to be hitting the ground and seeping into these underground aquifers in order to recharge that groundwater. That's especially a challenge in LA because impervious surfaces such as cement or any other pavement prevent water from being reabsorbed by the earth and instead flows across these impervious surfaces. This is called runoff, and it actually drains to the ocean. So whenever we have storm events in LA, all of the water that doesn't seep into the earth instead drains to the ocean, carrying with it litter, oil from roads and things like that. So storm runoff is a significant source of pollution in LA. And water that doesn't run off, or water that does run off, is water that could have been used to recharge the groundwater aquifers. Lastly would be groundwater contamination. So you can see that the San Fernando region is the vast majority of the local groundwater supplies. And unfortunately, there are some concerns about contamination of those drinking water wells with chromium-6, which is, I don't know if anyone has seen the movie Aaron Brockovich, but it's something you definitely don't want in your groundwater. And so there are remediation efforts and studies underway at how we can remediate the chromium-6 in our aquifers so that that water can be consumable. Looking forward to LA's water future, we have two different graphs showing kind of the baseline year for the City of LA's water plan, the water supplies, and then the goal for 2025. So as you can see, the goal is to have much more of LA's water provided from local supplies, planned local supplies, and then other locally sourced water. I'm kind of wishing that this graph included reduction, because water reduction and water conservation efforts can go a long way in towards reducing dependence on imported water. But the key takeaways here is that demand will continue to grow as more people move to the region. More water will be required for the region. More sourcing from local supplies, as I mentioned. Conservation will play a role. So I think during the droughts, more recent droughts, conservation efforts actually reduced demand from 16 to 19%. So that's all water that just wasn't even, didn't need to be supplied and taken from those other sources. Lastly, new programs and infrastructure will be developed and expanded. So some of the things on LADWP's list of strategies would be improving water recycling, so using gray water for irrigation, things like that. Rain barrels, so having residents collect rain and then letting that rain trickle back into the ground instead of it being runoff during storm events. And then the groundwater remediation, as I mentioned, or even capturing stormwater on a much larger scale and letting it infiltrate and recharge groundwater. So that was water for the city of LA. Next I'm going to dive into water, power, and sustainability, because current sources and methods that we use for water and power will not last forever, and hopefully humans will continue to thrive long after we've burned all of Earth's fossil fuels. Whenever we talk about sustainability, we often use the term triple bottom line, which refers to the three major impacts that any system has: a social impact, an environmental impact, and an economic impact. So these are the three pillars of sustainability, and no system can function indefinitely and be truly sustainable unless it is socially equitable, environmentally regenerative, and economically feasible. So let's look at those three impacts for our electrical systems. So as I mentioned, electricity uses a lot of water. In fact, it uses about 41% of all US water withdrawals. So out of all the water that the United States removes from natural sources, 41% of that is removed for the purpose of generating electricity. And about 10% of that is actually consumed in generating electricity. So, that 10% is lost as the steam that escapes, but a lot of that water actually recondenses and is used for cooling down the power plant. So that other 31% is typically returned to the source where it was pulled from. And it's returned at a higher temperature because it just went through a power plant that's burning fossil fuels. So the impact that has on ecosystems, and especially aquatic ecosystems, is that you're introducing all this water that's at a much higher temperature, which will obviously impact the health of plant life and animal life in those areas. Looking more at kind of the social impacts, we do see a lot more power plants in low-income areas. If you've heard the term "not in my backyard," no one wants to live near a power plant because they spew a lot of pollution, right? There are air quality concerns. So not only are more power plants located in low-income areas, but people in those areas are about 17% more likely to be hospitalized for asthma and other respiratory diseases. So that's an added economic burden of higher healthcare costs that a socially disadvantaged group is already is having to incur. Lastly, another environmental impact would be the carbon dioxide and greenhouse gases generated from burning fuels for electricity. So that 1 kilowatt hour you might see on your electrical bill that cost you 15 cents because you cooked a frozen pizza released over a pound of carbon dioxide into the atmosphere. And because I think it's really weird to measure gases with pounds, I converted that to gallons. So a single kilowatt hour releases about 72.5 gallons of CO2 into the atmosphere in LADWP territory. So what's the impact of all this additional CO2? Well, you can see here in this graph, since 1980, CO2 levels have been steadily rising worldwide. And this little cyclical up down is the seasons. So almost, winter versus summer. But overall, you can see the average is clearly rising. And if we look back more than 40 years, in fact, if we look back 800,000 years, you can see that CO2 has not been as high as it is now at any point, in Earth's recent history. So what are the impacts of that? Obviously, higher global temperatures, more intense flooding and wildfires, sea level rise, drought, loss of farmlands, and other impacts that we would generally like to avoid. How about water? So remember the LA aqueduct right here, which provided almost 30% of LA's water for that 5-year period. Well, it takes water from the Owens River, which would normally flow into the Owens Lake right here, and instead diverts it to the city of LA. So before 1913, when the river was diverted, Owens Lake was about 12 miles long and 8 miles wide. It was up to 50 feet deep in some places. 13 years later, in 1926, this is what the Owens Lake bed looks like. So it is predominantly dried out, and it is actually the single largest source of dust pollution in the United States, with 4 million tons of dust blowing away from that dry lake bed each year. That causes respiratory problems in nearby residents because there are, a lot of things you don't want to be breathing in that dust. Very low visibility for nearby roads and highways, as well as, the loss of farmlands and other natural ecosystems that would have been receiving that water. So desertification, dust storms, air quality, those are all impacts. There's been fierce opposition to this project from local residents since it began. And in some cases, actually local people dynamiting the aquifer as it was being constructed. The aquifer was constructed regardless, and now a lot of these arguments are being settled in courts. So as part of an air quality mitigation settlement, the LADWP has been flooding about 27 square miles of this lake bed with water to prevent dust from being blown away. They've also planted some plant species that are very tolerant of the high salt content in the soil, to help stabilize that soil, and added gravel as well to keep it from being blown away. All in all, they've spent about $1.2 billion on this project. So that's an enormous economic cost to LADWP, which is definitely being passed down to the ratepayers as well. Another issue that's entirely unrelated to this, but related to groundwater, is subsidence. So whenever you extract large quantities of groundwater from underground aquifers, the ground actually compacts because you're pulling this water out of it, which leads to subsidence, which is where the land, is literally sinking and becoming lower. So that can require construction to save those structures on the subsiding land, also a costly process. So now we will dive into water power at CSUN. So that was water and power and sustainability. So hopefully, you'll learn what CSUN is doing to tackle some of these issues. This is a pretty simple graph, just CSUN's water usage over the last 11 years. Rather than tell you how many hundreds of millions of gallons we use, I just broke it down into gallons per second, averaged out over the year, 24/7, 365. So back in 2008, we were using almost 9 gallons of water every single second as a campus. And now in 2019, we're just a little underneath 5.5, which is pretty impressive. That's almost a 40% decrease from 2008 to 2018. So in 10 years, cutting our water usage by 40%, pretty amazing. And from 2013, when we launched our sustainability plan, to now is about a 31% decrease. So we are pretty proud of that. How have we achieved that? Through efficiency and conservation measures. So the difference between efficiency and conservation would be that efficiency means doing the same thing with less water, and conservation would simply be using less water. So doing less and using less water as a result. A few of our initiatives around this involve metering. So obviously you can't change what you can't measure. So we've stepped up our metering so that we can actually measure water usage on a more granular level. And we're working on installing some automatic meters that'll give us water usage data every 15 minutes even, and can automatically detect leaks based on water usage profiles, so that we can be notified as soon as a leak is detected, rather than waiting a month until we get our water bill to learn that, oh wait, there might actually be a leak here. Another thing is low flow fixtures and plumbing. So we've swapped out the majority of fixtures around campus with low flow alternatives. So doing the same thing with less water basically. Drought tolerant landscaping, here's a great picture of one of those efforts. So about 50% of the water usage on our campus goes towards the landscape. So, in areas where we don't need turf grass, replacing that with drought tolerant plants has gone a long way towards cutting our water consumption. These drought tolerant plants, thrive. They're, native to Southern California, and they also tend to attract a lot more pollinators and other wildlife than turf grass would. So this is also tied into a few of our other initiatives around improving pollinator health as well. As I mentioned, half our water goes towards irrigating the landscape, so improving the efficiency of our irrigation system has gone a long way. We replaced really fine misting sprayer heads with some soaker hoses so that less water is lost to evaporation, as well as timing our watering of plants to be in the morning when temperatures are lower, so that you're not losing as much water to evaporation whenever you do water. Irrigation mapping as well. This was actually a student project where we had 3 female students through a grant from LADWP actually mapped almost all of the irrigation infrastructure on campus, which has given us a very detailed map of all of the sprinkler heads, all of the controller boxes, and this makes it very easy for our ground staff to identify and fix leaks, to train new personnel, and to optimize the overall operation of the system. Hydrogel injections is a really fun one. This little image right here is kind of an artist's rendition of that, but what we did is we found a company that'll actually come and inject this stuff into the root zone of turf grass. And what it is, it's all like an algae-based natural polymer that kind of functions as a sponge. If you ever had the tapioca balls in boba tea, it's kind of like that. But they inject that into the root zone, and then whenever it rains or whenever we water a lawn, all those little granules expand and absorb that water and keep it in the root zone for the lawn so that we don't have to water it as much the next day. And this has decreased the water consumption of the lawns where we've applied it by about 50%, which has been pretty significant. Lastly would be rainwater capture. So we have a cistern at the Chicano house on campus that captures rainwater, and then they're able to use that to irrigate their garden, or that's just runoff that was prevented by instead capturing it. So what has this resulted in? Well, since 2008, we've saved about 54 million gallons of water each year. That's an average. Of course, some years it's better, some years it's worse. But around 55 million gallons of water annually. And from a financial standpoint, that's very significant because we've saved $4.5 million since 2008. And it definitely did not cost us $4.5 million to do all of these projects. So that's definitely a boon for the campus. Moving more into electricity. This is electricity consumption in a typical CSUN building. I was actually surprised to learn that heating, ventilation, and air conditioning was only 1/3 of our overall power usage, and pretty shocked that lighting is almost 50% of our overall power usage. So if you look at your home's energy consumption, your air conditioner is probably a pretty significant amount of your overall usage, especially in an LA summer. But lighting is also up there, and of course plug loads, plugging in appliances, toaster ovens, things like that. On campus, that would predominantly be computers. This is my lovely rendition of our chilled water loop. So this is this is how we cool and heat the majority of our campus buildings. Right up here on the north end of campus is our central plant, where we have chillers and boilers. The chillers are kind of similar to your air conditioner in that they move heat to create this really cold material. And in our case, we create cold water. So that water is made in the central plant, requires a lot of electricity to cool that water down, but then we pipe it through this series of pipes all over campus to different buildings. And then once that cold water gets to that building, there are fans and other units that use that cold water to cool down air and blow that into the building so that we can sit in a 70-degree building even though it's 100 degrees outside. So one of the ways, actually I don't want to get ahead of myself, but that's electrical usage in a nutshell at CSUN. So a few of the ways that we have saved electricity at CSUN. Lighting efficiency is probably the biggest one. As you just saw, almost 50% of our electricity goes towards lighting in a typical building. So we are working on some projects to do building-wide lighting replacements in a few of our really big buildings on campus. We've also done some smaller projects throughout the past several years. Last year, we just finished replacing all of our outdoor lighting, so our walkway lights. Those were replaced with an LED that reduced the power consumption by 60%. And that project is saving us, over $30,000 a year just in electricity that we don't have to buy. Meanwhile, our students and employees are enjoying a higher quality light, as they walk around campus during dusk. Building envelope improvements. This is about, HVAC efficiency. So if a building envelope is not sealed properly, then a lot of that cold air you're spending energy moving into the building is going to escape, and a lot more heat from outside is going to get in. So by better sealing our buildings, we can prevent that air exchange and temperature exchange from happening, and have a more efficient HVAC system. Peak demand reduction. So TES stands for thermal energy storage. I'm actually going to go back. So thermal energy storage right here, I mentioned our central plant. Actually, you can see this from outside the plant if you ever end up back on campus. Then we have about a 2.3 million gallon tank of water right here. And what we do is fill that up with really cold water at night. And we do that because electricity is cheaper at night because fewer people are using electricity. So that means that during the day, when a lot more electricity is being consumed and power plants are kind of operating at their peak demand, we don't have to add to that demand with our chillers, to make more cold water because we already made it at night. So with that thermal energy storage, we're able to, save or reduce our peak demand on the grid, and also save money because, we're using a lot more electricity when it's cheaper. On-site solar production. So we have solar panels on the B2 and E6 parking lots, as well as on our sustainability center and student recreation center. Those produce about 1 to 1.5% of CSUN's electricity each year. Definitely does not sound like a lot, but that's all about $80,000 worth of electricity that we don't have to buy. So even though it's a relatively small percentage, it is a significant financial benefit. And that's electricity that was created without burning fossil fuels and releasing CO2 into the atmosphere. Equipment efficiency upgrades. Here's a great example of one of those over on the right. This is called a package unit, and it's basically an air conditioner and a heater all at once. So it uses electricity to cool down air with its air conditioning side, and then it uses natural gas and burns that to create heat in the winter whenever we need to heat buildings. But we have these on a lot of our buildings around campus, and they do use a significant amount of both electricity and natural gas. This one was on the roof of Jacaranda Hall, and we replaced it with this one on the right. And down at the bottom, you can see the different performance between the two. So the old unit, when it was on, it was always using 100% of its power. It was either on or off, and there was no in between. So even if we didn't need to be running it at max, it had no other option. So this new one that we put in can be ramped up and down depending on how much is needed, which means that it can be drawing a lot less power if it needs to be doing a lot less heating and cooling, which is great. I believe there were about 50% electricity savings on this project. Overall cost for this project, I don't remember what it was, but this basically would have around a 30-year payback. So definitely not the $30,000 savings a year that a lighting efficiency project would have. But as these pieces of equipment, fail and need to be replaced, we're definitely, looking at replacing them with the most efficient option. Last two, we have a net zero energy building on campus. So this is our sustainability center. And net zero energy means that it's actually designed to produce as much electricity and as much energy as it consumes. So that building has solar panels on the roof. It also has these flat black tanks that hold water. They sit on the roof and absorb sun and then heat that water. So we're just using the energy from the sun for water heating instead of burning natural gas to heat water for that building. And I believe the last time we looked at it, that building was generating about 80% of the energy that it consumed. So not quite net zero, but very, very close. Is a very high performance building. And lastly would be a LEED Gold standard for new buildings. So LEED stands for Leadership in Energy and Environmental Design. And this is a kind of a globally accepted standard for high performance buildings, energy efficiency, occupancy, well-being, things like that. So CSUN does have a gold standard. There's different certification levels: bronze, silver, gold, and platinum. And we've stipulated that any new building that goes up on our campus will be at least LEED Gold standard. So those efforts have gone a pretty long way towards, improving our overall energy efficiency. I believe that in the last 10 years, we've reduced our electricity used per square foot by more than 10%. And in that same time, we've added, we've grown the amount of buildings on campus by 25%. So even though we have 25% more buildings than we did 10 years ago, we're using 10% less electricity per square foot, which is pretty impressive. So I did have one more section that I wanted to talk to you about. Sorry, I lied to you in my outline, which is water, power, and you. So I wanted to include this slide because I did present some pretty harrowing information, and I want to address any feelings of urgency or concern that you might have as a result of that info. Firstly, I'd say that those feelings are totally valid, and it's a good sign that you understand that you are a part of these water and power systems, and that your interaction with these systems does have an impact, however small it might seem, on the health of other people and of our natural systems. So sometimes I get questions during these presentations like, what am I supposed to do? Like, am I supposed to not shower? Am I supposed to not use electricity? Obviously, you still have to take showers and use electricity, but you can take actions to significantly reduce your water and power consumption. So here's just a few of them. Purchasing LEDs for your home, replacing grass with drought-tolerant plants in your lawn, choosing more efficient appliances, turning off the tap when you brush your teeth if for some reason you're still leaving the water running when you brush your teeth. But of course there is a flip side to this school of thought, as is evidenced by this tweet, which my friend sent me a while back. So they said, oh, this made me think of you. This person said, as long as people think they can recycle, bike ride, and skip the meat to save the planet, we're doomed. So this pissed me off for a couple of reasons. Firstly is that I do all of those things, and if everyone just lived like me, we'd be doing better, right? But also because to me, this tweet is basically saying, as long as people feel empowered to reduce their waste, greenhouse gas emissions, and resource consumption, we're doomed, which is not at all a productive statement. And I think it's also way easier to sit on your ass and tweet about how we're doomed than it is to actually do something about it. But this tweet does have an echo of truth to it, right? Because not everyone has the opportunity to bike to work or the time to cook healthy vegetarian meals. So if you want to give this person the benefit of the doubt, I think that what they are really trying to say is that we can't just change how we interact with these systems. We have to change the systems themselves. And luckily, that is also within your power, right? There are sustainability initiatives that would not have happened on campus without the support of student government. If a significant percentage of our student population says, hey, we don't want to enter a contract with this beverage company because they, do X amount of pollution or whatever, that has actually happened at other campuses. So don't underestimate your voice as a student. And then in terms of planning decisions and policy makings, right, our students are the future architects and engineers and artists of the world, and they'll be making infrastructure decisions that impact the next several decades. So, you have the opportunity to address sustainability challenges in those decision makings, through your career, through your artwork, or whatever you want to do. Education is a pretty straightforward one, right? The more people who are aware of these challenges, the more people can address them. And then lastly, activism. So I don't mean activism as in marching in the streets. I mean it as in the opposite of passivism. I often encounter this drop in the bucket mentality where people just put on their blinders and say, oh, nothing I do will make a difference. It's up to the big corporations that created these problems to solve them, right? And to that, I would say that if you take the time to put your trash in the trash can instead of throwing it on the ground, then you know that your individual actions have an impact, and that if everyone littered, our campus would be covered in trash, right? If you vote, then you know that every drop in the bucket counts. You have dozens of opportunities every single day to reduce your impact. And if all you choose to do is go to the polls and check a box every 2 years and hope the policymakers do the right thing, then you're really minimizing your own potential. You shouldn't feel like it's up to you to solve all these challenges, because it's not. But I just want people to recognize how much of your personal impact is under your own control. So focus on the things that you can control to make them better, right? This is not a school assignment. You're not going to be graded on it. No one will hold you accountable except yourself and maybe your kids. But choosing not to hold yourself accountable for the things that are under your own control is a pretty dangerous mistake. And that's why I included this slide and why I'm challenging everyone to do better. So that is all that I had. Thank you all for listening, and I'd be happy to turn it over to questions.
Thank you, Nikhil. That was really informative. If people have questions, if you want to unmute yourselves or put it in the chat box and we can read your questions aloud if you don't want to take yourself off mute.
Hey, I had a few questions. The LA DWP water, like one of the charts was 2011 to 2015. Is there any reason we don't have any newer data, or is that just the only one that could be found?
That was the most recent data I could find. I would say the reason is that LADWP is a very large organization and they move pretty slowly in that regard. It probably took maybe not 10 years, but several years to put together that plan. So the most recent plan that they've released was in 2015. And so as soon as the next one comes out, I'm sure we'll have more recent data. But that was why I had to present, 5-year-olds figures.
Okay, cool. I was just wondering. And then I have a few more questions, if that's okay.
Yeah.
I wanted to ask about like the legality of collecting groundwater at your home or collecting rainwater. Is it completely legal to do so? Because I've heard some stuff about it being kind of sketchy in that respect.
In California, it should be totally legal to collect rainwater, I believe. I think a quick Google search would probably confirm that better than I'm comfortable with right now. As far as groundwater, there might be, I know in many places in California, you're definitely allowed to dig a well on your property. So that would be the question, is what restrictions are there in place in your local area on wells?
Okay, cool. And then my last question, are the solar panels all up at the top of F10? Are those for us, or is that some other organization that uses them?
So those were actually installed through a partnership, I believe, with Boeing, and they're kind of like these high-tech panels that they wanted to test. They're supposed to like track the track the sun so that they're always getting that maximum angle for maximum efficiency. And then they also have like this concentrating cell that like concentrates all the sunlight for one area into a much smaller solar panel. They're not actually active right now. I believe, I couldn't tell you exactly why. I believe it had something to do with the interconnection agreement about like hooking that solar array up to LADWP's power grid. We would love to do something with those solar panels because right now, it's a lot of wasted potential. But
Yeah,
those are the campuses, yeah.
But anyways, thank you so much for answering my questions. And I really thought your whole presentation was very thoughtful, and I really agree with everything you said. And yeah, just thank you.
Yeah, no problem. Thank you. Oh, I guess to follow up on the solar panel thing, they were also damaged by the wind. So the wind like spun them and kind of ripped some wiring loose. So, yeah.
Looks like there's a question in the chat. What are some additional actions the campus can take to reduce our water consumption?
Additional actions. I know one of the things that we do well right now is adjusting our irrigation schedules, in conjunction with rain events. So last year during the rainy season, we were able to turn off all campus water, all campus irrigation, I believe for 3 months, which is pretty huge. That was 3 months that we just weren't running our irrigation at all, which is pretty significant. A few other things that the campus can do is look at reusing condensate. So in our cooling towers at the central plant and satellite plant where we make hot water and cold water, a lot of condensation forms on the pipes that transport cold water, and you can actually recover that condensation and use it for irrigation, or whenever you have to use water to flush out the cooling towers. It's called blowdown because sediment and things will accumulate over time. So you blow them down and use a lot of water to flush out the sediment, but you could capture that as well and use that for irrigation. So we are investigating a few of those opportunities. Tanya asks, is there any way we can still use runoff water? So this is something that we've looked at a few different times. Most recently, we had an urban planning class do an analysis of a few different locations on campus. Lindley Avenue is a great one. We have lots of water flowing down Lindley during those storm events. So they looked at ways to maybe really dig a large pit in the ground and then fill that with gravel and other sediments, which creates a really large volume space for water to flow into and then sit in and trickle down into over time. We haven't really pulled the trigger on any of those initiatives yet because the initial cost of doing them is pretty high, and the payback that we would achieve is relatively low compared to that cost. So water, the campus pays less than a penny a gallon for our water, which is very, very cheap, and it presents a challenge because it means that whenever we're saving a lot of water, we're not necessarily saving a lot of money. So that would be one of the obstacles to using that runoff water. The other would be that it is flowing over roads and streets and, asphalt. So it's pretty dirty. And there's a lot of remediation that we would need to do before we can just put it onto our planters or things like that. So all that to say, it's not impossible, but at this time, it's not like the low-hanging fruit for water conservation. So we'll be tackling other ways of conserving water and solving these water challenges before we get to that one, just because the cost versus benefit is somewhat low. See, we have another question. Do you think we can replace the toilets and toilet paper with composting toilets and bidets around campus in the nearby future? In the nearby future, no, but eventually I think we could. Actually, the Sustainability Center kind of pioneered the composting toilets. They were the first ones through the door on that. So that building has 3 composting toilets in place, I believe. A few challenges have arisen with those. One would be the maintenance. They're much different to manage than this typical plumbing system. So our on-campus plumbers don't really have the expertise to be messing with them a whole lot, nor do they want to, because it's a lot dirtier than a typical plumbing setup. And actually the ones that they were testing, I think, or that they had installed were limited to about 15 flushes per day. So, in Sierra Hall, for example, a really large classroom building, that would require, hundreds and hundreds of toilets to accommodate the number of people using that building. Composting toilets are great, but they're not super effective for really high volumes of waste in a small space, which is what we have with CSUN, unfortunately. So, switching to composting toilets would be a very significant infrastructure project, probably way too expensive to do to existing buildings. But what we could do is that whenever we put in new buildings, try and assimilate some of those more sustainable natural systems. Bidets I know bidets are getting a lot more publicity right now due to toilet paper shortages. And you're not the first person to mention that in conjunction with our zero waste goal, which is, interesting. I don't know if how badly people want that, or how badly, to what extent the campus would utilize that. So yeah, I can't really answer that one. I will say that bidets are not really on our radar at the moment. Yeah. How can we lower our water footprint on campus regarding the food restaurants we have on campus? So that's a great question, Yaneli, and this is one that we've partnered with CSUN Dining on for a number of years, actually. It's not getting a lot of publicity right now because no one is on campus, but during Earth Month, they typically do Meatless Mondays, where all of the to-go food in the Freudian Sip locations, like those pre-made sandwiches and whatnot, are all meatless options. Because as I mentioned, animal products tend to have the highest water footprint. So initiatives like that, I would say that providing more vegan and vegetarian options will go a long way as well. I know that I think all of the dining locations on campus typically provide a full protein vegan option and vegetarian option as well, on their menu so that people are able to make that choice. I think that incentivizing that choice could help. That's another conversation that would have to be had with CSUN Dining, because they do control all those food operations. But I think that they could figure out ways to incentivize people to choose the low water intensity options.
Can I just add something to that too, Nikhil? You talked about embodied water in your presentation. And so one thing that people can do on an individual level as well is bring reusables. So, all those disposable products, when you get your Freudian Sip coffee, those disposable products have a lot of embodied water that goes into the manufacture and packaging and shipping of them. So every time you bring your own reusable cup, you are helping to reduce the water footprint of those products as well.
Yeah, that's a great point, Sarah. A typical water bottle takes about twice its own volume in water to manufacture. So if you have, a 20-ounce water bottle, it took 40 ounces of water just to make that plastic. So even if you're recycling that plastic, that was still water that didn't need to be consumed because you could have just used a reusable bottle. The paper coffee cups are another great example. Paper is very water intensive because you're growing trees and then the process of actually manufacturing paper is very water intensive too. So avoiding those single-use products will go a long way.
Does anyone else have questions for Nikhil, or just in general about water conservation at CSUN or at large? I put a couple links in the chat as well. So we have a whole series of events for Virtual Earth Month. So you guys can check that out. We have a calendar of a bunch of things going on for the next few weeks. And then I also put a survey in the chat. If you guys can just take like 2 minutes to complete the survey, that way we can send you out the recording of this as well as any resources that we talked about and get some feedback from you about the presentation.
I think there was a typo in the survey that had today listed as the 17th. I just wanted to let you know.
Oh, thank you. We do have a session tomorrow about green buildings if you're interested. So that one is tomorrow at noon.
Yeah, so the LEED certification that I mentioned, Colleen Barsley, who is our manager of energy and utilities, she'll be talking a lot more about that tomorrow.
Thank you for doing the survey.
Awesome. Thank you guys so much.
You're welcome. Do you take full credit for all of the solutions? Do you take full credit for all the sustainability solutions that were presented, or was it yours and the sustainability committee? So we have several different sustainability committees on campus. We call them working groups. So the sustainability plan laid out 10 different areas of focus, which would be waste, water, energy, transportation, administration, education, purchasing, environmental quality, a few others, but 10 total. So each one of those sections has its own working group. And those working groups convene to identify the priorities that we'll be working on for the next year, and then kind of, problem solve and figure out solutions, which ones we want to pursue based on how much funding we have. So I definitely cannot take credit for even half the sustainability solutions that were presented. I've been involved in a number of them, but and that's not to say that all of them would have happened without my input, but it's definitely a team effort. We have myself and then our director of energy and sustainability and our manager of energy and utilities. So there's 3 of us on the facility side, and then on the institute side we have Sarah and Dr. Zappia, the director of the institute, who work a lot more with students and on the academic things. But really, I would say that pretty much every sustainability initiative on campus is a collaboration, between lots of different people. I mean, we wouldn't have, swapped out all those fixtures without input from the plumbers. Our ground staff has been really, really receptive to new ideas. They've been handling all of the drought-tolerant drought-tolerant landscaping projects. They worked with us to make sure that the hydrogel injections would meet our needs and are working like that. So it's really a team effort. Yaneli Hera asked, where can I find more recorded sessions like these? So we'll be making these recordings available on YouTube. The CSUN Sustainability YouTube channel has a few different videos on there, but I'll be creating a playlist of all of our Earth Fair webinars so that you can find, we did one on transportation last week. We focused on waste the week before. The Institute has hosted a number of sessions on gardening and urban gardening. So you'll be able to find those on our YouTube channel, hopefully by the end of tomorrow, but definitely by next week. Question, why is it so difficult to connect solar panels into the grid? Houses are wired to accept electricity from solar panels. So I think one of the reasons that we have difficulty is because of the scale on which we're doing it. We're putting in very large solar panels that are generating a lot of power. And one of the requirements that LADWP has is that if we are generating above a certain threshold, then we have to put in this piece of equipment called a Vista switch, which is roughly $1 million. And what that piece of equipment does is it allows them to remotely connect or disconnect our solar panels from the grid. So the reason that would be necessary is that if there's a power outage and they need people to be working on the power lines, those power lines need to be dead and there can't be any electricity being fed into them from our solar panels, for example. So they're requiring us to buy this $1 million piece of equipment so that they can shut off our panels in the event that they need linemen to be working on the lines. And that drives up the cost of solar projects pretty significantly. So that would be, yeah, that's one of the funding would be one answer. And then from the CSUN LADWP perspective, kind of feels like a cop-out, but I'm going to say bureaucracy. There's a lot of moving parts and a lot of agreements that need to be signed in order to make that happen. And I think if you're really curious about it, I think this might be relating to the panels up on the F10 spot, but Austin would be able to tell you in more detail about why those specifically are not connected. The other reason, I guess, a common question is, why doesn't CSUN have more solar panels? So as I mentioned, the cost of the Vista switch will drive up those projects pretty significantly, drive up the total cost significantly. And then the other reason that we're not just going all in on solar is because we're not able to take advantage of power purchase agreements. LADWP is different from a lot of utilities in that it's not owned by investors. It's a public entity, right? It's owned by the city. And in the charter for LADWP, they've stipulated that no one can sell power to anyone else in their territory, which means that we can't take advantage of pricing structures that we could in other, utility territories. So a power purchase agreement is basically where we would pay a company to build solar panels or install solar panels on our campus, and then we would buy power from them. We're not able to do that because we're in LADWP territory, which means that we need to buy and install the solar panels ourselves and operate them, which is a lot more expensive because for a couple of reasons. Firstly, we don't have a tax appetite. We're a tax exempt institution. And so we can't take advantage of the 25% tax break on solar equipment like a private company would if we were able to contract through them. So that further drives up the cost of the project. And so, we've crunched the numbers for years and years, and really the solar projects that we're looking at wouldn't pay for themselves. We wouldn't recoup the initial investment until around 20 years in the future, or around the lifetime of the equipment itself. So from an economic standpoint, that's just not a good investment. We are pursuing a lot of different alternatives. We've, doing everything we can to get more solar on campus. But that's kind of some of the challenges of that in a nutshell.
Okay, I want to be mindful of everybody's time. We have about 1 minute to go. So if you have any last burning questions, now's your last chance to get them in.
Oh, Austin just posted another good answer to the F10 solar array in the chat, if you want to read that as well. Basically, he said that there's not a lot of electricity needed up at that site. And so we'd be spending a lot of money to put in this generation that's not necessarily needed. And so instead that power would be going back to the utility company. Sorry, did I cut you off, Sarah?
No, I was just going to read what you just summarized. So
Oh, okay. Great.
All right, so with that, I think we're going to wrap it up. Like I said, if you filled out the survey, we'll send you out the recording of this and then the link to our future events as well. So I want to thank everybody for participating, and a big thank you to Nikhil for doing this presentation today. It was very informative and inspiring. Hopefully you guys all found some tips of things that you can do individually and on a bigger picture to take action to help reduce your water usage.